making this example up, so it is claimed that the growth rate of a plant is different based on the type of fertilizer used, calcium rich, phosphate rich, nitrogen rich, and plants were observed at a fixed time point since they were planted. The rates are shown up there. They are percentages, which is why we have decimal values. And of course, if you want to compute a rate, you need to have a specific reference point, right? Relative to that reference, you saw this rate, but I'm not going to specify that bit here. All I'm telling you is these elements. That said, Ca, calcium, K, potassium, and nitrogen. So small samples, and we want to know if the growth rates depend on the type of fertilizer. Alternative, they don't. So no. And the treatment effect due to calcium-based fertilizer or calcium-rich fertilizer is the same as potassium, same as nitrogen. What is the alternative? At least one of them. See, it's a big thing. It goes through my mind all the time. Should it be at least one is different? At least one are different? Well, I think it is.
But I don't know.
I don't know. We have to Google it. No one knows. The reason why I go back and forth is when we say at least one, it's actually plural because it is one or more, right?
Well, then if you do the at least one's different, then it's just an apostrophe. You take the apostrophe is. But I don't know.
Google is our friend. Okay. So first step is to rank. The key difference between this one and the previous problem that we did is here we have ties, and we know how to adjust the ties. So the smallest one is 0.32. We have two of them. So if they were different, I would have assigned 2 and 3 because they are the same. Going to do the average of 2 and 3, which is 2.5. What should the next rank be? 4. And I believe that goes to 0.4 here. The next one is 5. 5 gets assigned to 0.44. 6 will get assigned to 0.48. 7 would be to 0.52. I have 2 of them. So 7, 8, average of those two, 7.5. 7.5. What is the next one? Next rank, 9. So 10 would be assigned to 0.6, but I had 2 of them. So the average of 10 and 11 would be 10.5. What is the next rank? So 10, 11, the next one has to be 12. The average of 0.67, that will get a 13, that's 14. Average of 13, 14, 13.5. Nope. Spoke too soon. that's 12.64. That would be 13. The average of 14 and 15 is 14.5. And last one has to be 16. So N1 is 6, N2 is 4, N3 is also 6. Sum of all of those would be 16. And the maximum rank that you assign cannot exceed 16, obviously. We know how to find the sum. So the sum of all the ranks, the first one is 27, 42.5, 58.5. Sum of all the ranks, second case 21.5, third one 56. Yes. Now, how do we define H? Well, H is 12 divided by n times n plus 1. I believe I used J. That n would be the number of groups that we have. I used lowercase n last time in the formula, correct? Because I don't want to confuse you guys. So what do we get when we plug it in the formula? This would be 12 divided by 16 times 17. 58.5 squared over 6, 21.5 squared over 4, 56 squared over 6, minus 3 times 16 plus 1, we get 17. Yes? And what does it come to? 2.32. Should we use H as is in this form? Or should we make an adjustment? I will go out on a limb and say we should listen. I think that's paying attention. Literally go out.
Yeah, I understood. That's why I did a little smile, because I wasn't sure if you.
Honestly, pay attention. So we have to adjust for a time. Now, you may think, oh, that seems like a very complicated formula. Not really. That formula is very similar to the Wilcoxon formula that we had seen before, at least in the way we write that part. If you look at Ti cubed minus Ti, I can write that as Ti common factor. It comes out, I would have Ti squared minus 1 Yes? But algebra, what is a squared minus b squared?
A minus b times a plus b.
A plus b times a minus b. If you go back and look at Wilcoxon formula, you would have had a term similar to that, don't we recall? Denominator, we had n times n plus 1 times n minus 1. In one of those cases, same argument, you would get n times n plus 1 times n minus 1. If we don't have any ties, how many groups do we have? 3 groups. We'll only look at the ones that have a tie. We don't care about the others. So how many observations are tied in the first group? 3. 3? Is it 3 or 2?
We're tied in another group.
Within the first group, 2, right?
Oh, 2.5, 14.5.
Oh, the 2, oh, I
Right.
see.
2
Okay.
here.
Yeah.
Tied 2 there.
And then so
2 there, and then there is a 7.5. So there are 4 groups actually, yes? And every single one of them has 2 observations. Yes. So we will have h prime equals h over 1 minus some 1 through 4, all 4 groups. An easier way to look at the number of groups is to see how many unique decimal values you have. And within each group, if you want to determine the number of observations, you simply look at the identical values. 2 7.5s, 2 14.5s, 2 10.5s, 2 2.5s. Yes, so 2 2 2 2. They're all the same, so we would have 2.32 over 1 minus 4, 2 cubed minus 2. Do a little bit of magic. 4, 3, 2. So h prime is equal to 2.32 over 1 minus 3 over 510. Yes? I just simplified it. Huh?
So not added.
And what is the final answer? Probably 2.3 something, right? $2.34. That's my guess. Make sure you put parentheses properly. So h prime is 2.33, and we know the test is always right out. 0, rejection region somewhere over here. Alpha let's assume 0.05. How do we find the critical value? So pKw would be used to find the p-value. We want ckw. Again, if you want to use this, you will need the NSM package. So 0.95, the reason being alpha is 0.05. They're using alpha, so let's just put 0.05. And number of observations, which is 16. I believe they did this way. And we end up getting 5.75 as the critical value. 5.75 is over here, and 2.33 is over there. Should we reject them all? No. We do not reject the null. In other words, what is the answer to part A? Are the growth rates dependent on the type of fertilizer? No. Now that I answered that, what about B? You tell me.
Any that you choose.
Anything that you choose, it really doesn't matter.
Right, the cheapest.
In terms of growth rate, it really doesn't matter which one you choose because they're all statistically the same. But if money becomes an issue, you just go for the one that is cheaper and that increases your profit, etc. Are we clear? Wait, yes.
That's it for each, because they're the same.
Huh? The answer to B is it doesn't matter which fertilizer is going to be beneficial in terms of growth rate because they're all the same statistically. No difference between the three fertilizers.
But A was yes.
Now, if A happened to be yes, then our conclusion would be one of them is different. In that case, how would you pick? Oh. For this case, you don't. If A happened to be yes, how would we pick the fertilizer? You can go back to the data here, find the median of each of them, and pick the one that has the largest mean. Okay. In non-parametric statistics, typically we go for the median. Parametric case, mean. To find the p-value, that's odd. This worked last time. It just wants you to specify the group label. And you can see that it is giving us the value of 2.32. They didn't do the adjustment. So the reason being, oftentimes beyond a certain value of n's, the adjustment is not a big deal at all. It's not going to change your conclusion. How do we do a large sample approximation? What distribution should we use? Come again, Chris?
I'm not sure.
Chi-squared. It's not chi because chi is the distribution in and of itself. So chi-squared distribution. We need the degrees of freedom. What is the degrees of freedom? Two. It's k minus 1 or n minus 1. Number of groups minus 1. So 3 minus 1, I get 2. We want to find that critical value. In our, you could find critical values using Q norm for normal, Q Wilcox for Wilcoxon. Here it is Q chi-squared. So Q CHISQ. You always enter the area below. The area below here is 0.95 because the area above is 0.05. Degrees of freedom, 2. End up getting 5.99. Yes? 0 is over here. 2.33, perhaps somewhere over there. Did the test statistic fall in the rejection region? No, so the conclusion is the same. What about the p-value? This is a right tail test, so for a right tail test, the p-value is always the area above the test statistic. You just put the starting value, 2 points. I'll do this thing. Oh, so p chi-squared. Starting value is 2.33. DF is 2, but we want the area above. So in R, you have to specify lower dot tail equals false. That is giving us a p-value of 0.3119. Yes. When it comes to chi-squared, we can use the calculator here to find the p-value. So we use normal CDF to find p-values using normal distribution. Here, press second bars. If you scroll down, you'd find option number 8, which is chi-squared CDF. Starting value would be 2.33. What is the ending value or the upper end point? Infinity, so second comma, followed by 99, you get E99. What do you think the last argument should be? But normal CDF, it was 0, 1. Here, if you have to take a guess, it has to be 1, 0.
I'll reverse it.
What is the parameter for a chi-squared? What do we need for a chi-squared?
The degrees of
The degrees of freedom, 2. 0.3119. Good.